All right, guys, happy Monday. Happy Memorial Day for those of you guys who are watching this today. This is Miss Leslie and Miss Margaret, and we are here for day number 11 of matrices. And today we're going to look at kind of using our matrices to help us solve systems of equations. Now, yes, these are going to all be ones that you could do by hand, but we're going to show you guys how to do them using a matrix instead. So Miss Margaret, go ahead.
Yeah, so today, guys, we really only have an example for you. This shouldn't be too bad. It shouldn't be anything horrible. So yeah, with that, I only have one example for you guys, and then that should be the end of your notes for today. I didn't want to overcomplicate it, so yep. Okay, so typically when you learn how to solve systems of equations, you learn substitution, elimination, those kinds of good things. And they're great, but we're going to show you how to do them with a matrix, which is also super simple. So what we need to do is take these two equations and put them into a matrix. So we are going to end up having three different matrices. One is going to be our coefficient matrix, one is going to be our variable matrix, and one is going to be, I forget what they called it, the answer matrix.
I call it the solution or
matrix. Okay, yeah.
Yeah, right-hand side
matrix. So we're going to have a coefficient matrix, a variable matrix, and a solution matrix. Okay, so for the coefficient matrix, that's the one we're going to do first, and it's going to end up being a 2x2 matrix because we have two variables and two equations. So you're going to need to put in the variables exactly how you see them here. So if you look at this box here, that is our matrix. We're just going to take out the plus and minus in the two variables. We're going to have 3, 1, 2, and -1, just like that. And then what comes next is the variable matrix, and that's going to just look like x and y, because those are the two variables we have. Now, I know that it says 3 and 1, and 3 is the variable for x, and the coefficient for x, and 1 is the coefficient for y, but that's the order that they go in so that this works. So don't think that you need to move things around so that they match up with x and y. You literally just take those four coefficients and put them into a matrix. You don't need to move them around. They don't need to match up with the x and y. You just are taking them and moving them down into a matrix.
Yeah, think about how multiplication goes for matrices, right? So it goes row by column. Mm-hmm. So the 3 would get multiplied to the x. The 1 would get multiplied to the y, and then they would get added back together. So if you wanted to take this out of the matrix, you could just by using matrix multiplication. So the reason why it has to go, the 3 and the 1 go straight and the x and the y go up and down is because that's how matrix multiplication works. So don't overthink it. This is where everything goes. Don't move stuff around. Coefficients go row by row. Variables go column, that go in their own columns.
And then your solution matrix is also just going to go 5, 0, just like that, just like you see there. And then from there, you solve like we taught you last week. This is just an equation at this point, and you're just going to solve like we taught you last week. So what we need to do is we need to take this matrix and we need to move it over here. Normally in like a normal equation we would divide, but since we don't really have division in matrices, we're going to find the inverse, and so we're going to need to find, I'm going to call this matrix C for coefficient. We need to find the inverse of matrix C, so we're going to have 1 over the determinant, 1, -1, -2, 3, and then you flip the 2 and you change the 2 signs, and you end up with 1/5, 1/5, 2/5, and 3/5. And then you're just going to multiply that to both sides of your equation. So remember the order matters here. So we're going to have 1/5, 1/5, 2/5. And it's going to end up on this side, 3, 1, 2, -1. Oop, forgot my variables. Like that. And then you're going to have them on the same side here, multiplied by your solution matrix. And then from there, this cancels, and you're going to end up being left with.
Oops, slide the screen down.
Oops, sorry, guys. There we go. And you're going to end up being left with 1, 2. I don't want to do all the matrix multiplication. You should know how to do that by now. And I did it this morning. So this is what your solution is going to end up being. So your solution is just going to end up being x is equal to 1, y is equal to 2. And if you want to check, you can just plug these two solutions back into your original equations. And that's pretty much it. Nothing too bad, nothing too complicated. That's about it.
Yeah, excellent. So as long as you put everything in the matrix correctly, it should be pretty easy. You can do this by hand. You also could just put this into your calculator if that seems easier for you. So yeah, but that is using a matrix to solve a system of equations.
Mm-hmm.
Everything in the matrix, like Ms. Markert said, it is exactly like solving the equations that you guys were doing last week. You have your coefficient, and then you have your variable equals sum matrix, and you just want to get the variable by itself, move it over to the other side using inverses. So yeah, hopefully that wasn't too bad. Today on your homework is all going to be solving two equations, 2 variables. Tomorrow we'll pick it up and we'll do 3 equations, 3 variables, which is something you guys definitely don't want to try and do by hand. And then you can see how matrices really make life so much better. All right, but that is it for today, guys. Hopefully you have a good rest of your day. Hopefully the homework goes pretty easily, I would assume. And we will see you guys tomorrow. Bye.